Hi, today we will discuss NMR Spectra of Paracetamol. I hope you have some idea about NMR Spectra. As this is part 1, today I will tell you the basic things about the NMR, what is the objective of it. Before to that, just write down the aim we do today. I hope the screen is visible to everyone. Okay, this is the aim. To interpret NMR spectra of unknown compounds. As this is the first class for the NMR, so we start with the paracetamol. Before to that, you should know what is the objective of doing the NMR. Why we do it? In the NMR, we came to know about proton and carbon. It is basically nuclear magnetic resonance. In this, we know about how many protons are present in the given compound. As the aim is clear to everyone, this is for unknown compound. When we know basically organic compound are the combination of hydrogen and carbon. If you know about how many hydrogen are present in the given compound, how many carbons are present in the given compound, we can elucidate the structure very easily. Right? In the structure elucidation, we discuss NMR in detail. Fine. So we start with the PCM. So I draw the structure of acetabol. Now you can tell me how many types of hydrogen are present. You can see the spectra. There are the different peaks. But first of all, you need to tell me how many protons are present and how many types of protons are present. Types of protons mean it contains aliphatic, aromatic, and free protons. Aliphatic means their value is less than 3. Aromatic means their value is more than 3. And free means whose value is this pair in the case of D2O exchange. If you know in detail about D2O, I'll make the separate video for that. Now we discuss first aliphatic. All the three protons come at the single chemical shift. For that, firstly I draw a laboratory structure. Now you can see carbon is joined to three protons and all the protons have same environment due to which all the protons have same chemical shift. Now we come to the next neighbor also. Generally, I say we are not concerned about the neighbors, but here we should concern. How many protons are present in the neighbor that are helpful to calculate the coupling constant of the current nuclei? Fine. Here, neighboring proton, there is no neighboring proton. It means the chemical constant value is n plus 1. Here, n is 0. Fine. Now, calculate it. If n is 0, what would be the coupling constant? Do it by yourself. 0 plus 1 means singlet. Fine. This is for the first aliphatic protons. All the three comes at the same chemical shape and the coupling constant is singlet. Now, next is free protons and the aromatic protons. Fine. Here, as I already told you, free protons they are displayed in the DT exchange. With the help of that, we can confirm free protons are present and their chemical shift is very small as compared to the aliphatic and the aromatic protons. Fine. You can see the small shifts correspond to free protons. Okay. Then next is now aliphatics are over. Now next is the aromatics. How many aromatic protons are present? Four. And two protons have the same environment, so they have same chemical shift. So you can see all these aromatic compounds, protons, they have same chemical shift. Now we need to calculate their coupling constant. As in the neighbor, there is a one proton. So 1 plus 1 means 2. It appears as a doublet. Right? Okay. In this way, now you need to tell me how many protons are there in the structure. In total, there are the 9 protons are present. Fine. Out of which 3 are aliphatic, 2 are the free, and 4 are the aromatic. Fine. So, in the files, you need to write down their shift, their nodes, the reference to that protons, and their coupling constant. Now you can pause the video and take your notebook and write down what you can the points should be mentioned in your and write down the same in your files. Fine. Because when I discuss, everyone know that but when you're supposed to write in your notebook and you forget. So make a heading from the video and write down the same in your practical file and paste the spectra on the left side. Fine. Notes and as you just start with the NMR, so we are supposed to write down the increment, the decrement. Just write down the reference group. Like if it is CH3, it corresponds to aliphatic or it is aromatic or the bonded protein. Just write, that's it. You're supposed to write it in detail. Along with that, you're supposed to mention the coupling constant in detail. Fine? That is very easy. Otherwise, there are the advanced version also like doublet of double doublet, triplet of doublet, quadret. In detail, I'll discuss in the next video, part 2. Fine. For today's class, up to this only. If you have any query, any issues, feel free to contact me and just write down the things on your practical file. That is the takeout of the today's session. Coupling constant, NMR, paracetamol spectra, bonded proton, and how we came to know the three protons are present in the given compound. That is the D2 exchange. I would like to make a separate video about the D2 exchange. Fine. Till that, stay tuned to the channel. And if you have any query, welcome. Do not forget to share and like the video. Fine. Thank you so much. Stay blessed. Thank you.
die haben dort, wo den, du sollst, noch so eine Störung,